ahead.
Okay, so my experiment was growing plants aeroponically. Oh, that's not there, okay. So what is aeroponics? It's a type of farming in an air or mist environment rather than soil, and it's one of 3 types of vertical farming, and that's hydroponics, aeroponics, and and hydroponics. And why should we care? Land, currently the size of South America is used to grow land, and by 2050, if the population trends continue, there will be 9.5 billion people, and we will need another Brazil's worth of land, and that's not really possible. Fresh water, 70% of the fresh water goes to agriculture, and then due to pesticides and fertilizers and all of that, it's not drinkable. GMOs are a short-term answer because, once again, the land comes up in the fresh water, and then deforestation. And GMOs are also short-term answer because climate change, if it continues, and it will, the climate will change too quickly for GMOs to really work, because the it won't be able to happen. And then deforestation, the more the forests die, then the less deforestation will have to happen if we continue to take down trees for growing agriculture. So the question is it possible to grow plants such as beans in a DIY aeroponics garden with no aeroponic solution? My argument was that a sufficient amount of solution is needed to grow the healthiest plants possible aeroponically. My method was to germinate the seeds, and I did this for 1 to 2 days until they were germinated, and you could see the starts of the root. Then I put them in dirt for about 4 to 5 days until they were at least 5 inches long. And then I put them into 3 different buckets. One had all of the solution, which was 5 milliliters for 3 gallons. Another had half of the solution, so 2.5 milliliters. And then the other one had no solution. And then every day I measured the height of the plants and the leaves. My results, the plants with 5 milliliters of solution grew an average of 14 leaves from day 0 to the last day. The plants with 2.5 milliliters grew an average of 12.17 leaves between the first and last day, and then the plants with no solution grew an average 8.5 leaves. The same thing happened with the height. The one with the most solution grew the most. Second, the one with half the solution grew the second best, and then the one with no solution had the worst results. For the height, the plants with the 5 milliliters grew an average of 10.22 centimeters. The ones with half the solution grew an average of 7.48 centimeters, and the one with no solution grew an average of 5.58 centimeters. So my conclusion was that, so my argument was that a sufficient amount of solution is needed to grow the healthiest plants possible aeroponically, and my conclusion was that you need to use 5 milliliters of solution for every 3 gallons of water used to grow the healthiest plants, and my data backed up my argument. Since all of the plants with all of the solution had the most growth with the leaves and the height, the ones with half the solution had the middle results for the leaves and height, and then the no solution had the least amount of growth. So implications, the outcome is that the more solution the plant had, the healthier it was, and it means that if someone wanted to grow healthy plants aeroponically, they would need a sufficient amount to grow the healthiest. And in future studies, different solutions and different types of plants like soybeans or mint or etc. could be used to see if the results stay the same. So they could use different families of plants as well, not just beans. So it could be ferns, flowers, whatever. And future studies can try and find the ideal amount of solution besides just all the solution, half the solution. No solution, it could go a little bit over, a little bit under, and can just like narrow the scope and narrowing the range of concentration. And then references.
Cool. Jen?
Okay.
Go ahead.
So, no, my question has two parts. So it's that, in this specific part of your research process in which specific part of your research process was your expert advisor most helpful? And how was he or she most helpful? And then part two would be, what did you learn from your expert advisor about your field of research?
I didn't have an expert.
Oh, you didn't?
advisor,
Okay.
So yeah.
Which of your sources was most influential, and in what ways is that influence apparent in your final conclusion or result?
Mine was the first citation, the rise of vertical farms, because it had a lot of information about aeroponics and what it is and what it could mean for the future, and then also methods to grow. I didn't use the method that was in it because it was too complicated and too advanced, but I think that was the most helpful.
Thank you.
Okay. What additional questions emerged during your research, and based on your recent experience, what advice would you give other researchers who might choose to investigate those questions?
What was the first part?
What additional questions emerged during your research?
Additional questions, it would probably be, again, the ideal amount for narrowing the concentration, or in testing other things such as the weight of the plant from the beginning to the end, or just more information, or the length of the roots, or something like that.
What advice would you give to other researchers who choose to investigate those problems?
I would give them the advice of making sure that you're on it every day, and to follow the method that would most work for you.
Sorry.
That's all right. So after you chose your research question, which information guided your choice of a research method? I'll let you answer that.
What was the second half?
What information guided your choice of a research method?
The information about I guess the information about the information about what aeroponics is and what the methods could be used, and what could be helpful to grow plants aeroponically.
All right. Great.